This is the final project of the ACES program, the gray code to 7-segment display decoder. By turning this gray code encoder, the 7-segment display will count from 0 to F in hexadecimal. So if I turn this, you can see that the 7 display will go up. However, my circuit isn't wired correctly, so a couple digits are missing and aren't lit up properly. So there's 0, F, A, 9, C, 3, E, 8, and 6. So here's how this project works. The fundamental concept of this project is K-maps or Carnot maps, and they basically allow you to simplify Boolean algebra expressions by showcasing their truth tables, showing when a function is high or low. So right here, I've drawn the K-map for segment A, and basically the table here shows when segment A needs to be lit up or needs to be 0. So I've determined that by figuring out for which digit from 0 to F, as that's what the gray code encoder counts up to, should be on. So for example, for number 0, all the segments are on except G, so A must be high here. However, for 1, only B and C are lit up, and A is low, so it must be a 0 here. So I've done that for each digit from 0 to F, and I put a 1 where segment A is high and 0 where it's low. Okay, now I can create a Boolean expression for this function. And to do this, I need to find which set of variables are in common with each row and column. So I'll start with the first 4 ones here. I notice that both A and B are low, and the output is independent of the inputs C and D. So it doesn't matter what C and D are, I just need these 4 inputs to be 1. And I can express that by writing not A, not B. Now I'll focus on the 4 ones in the center. I notice that A is high and C is high as well. So that's the next term. AC. And now I'm going to focus on the 4 ones on each end of the table. And the reason I'm not going to write the Boolean expression for each of them independently is that I'd use a more complicated Boolean expression and have to, so I can group them instead. So I noticed that A is low for both of them, and so is C. So I'm going to write not A, not C. And basically the bar over the letters means not high. And now I'll focus on the 2 ones here. And I notice that B is high, but C and D are both low. So I'll write B, not C, not D. And now I'll focus on the final one here. But if I just focus on this one here, the Boolean expression will have 4 variables, and in order to minimize that, I can just include these 4 ones here, which are not B and D. That expresses the 4 ones here, so that's the next expression, not B, D. And in order to find the total number of gates used in this K-map, I have to count how many ands, ors, and nots are used. So I can see that there are 1, 2, 3, 4 ors, 1, 2, 3, 4, 5, 6 ands, and 1, 2, 3 unique nots. And this is basically done for each segment on the 7-segment display, and I've used the correct number of chips to use that. Thanks for watching. This was my final project in the RSGC ACES program, and I'm so thankful to have been in this program for the past 3 years. I've been exposed to so many great projects, people, and of course Mr. Darcy. I'm so thankful to have learned all these concepts, and I can't wait to see what the next few years have in stock for me. Thank you again, Mr. Darcy.